All right. Hello, everyone. That's okay, Matt. I will have to contact the tech people to see how to change that. So I'll accept everyone today. Thanks, though. Okay, so hello. We are going to review for chapter 4, and the test is tomorrow. Just kind of giving you a glimpse of what the test will look like tomorrow, just to have an idea. There will be 4 proofs again, just like the quiz had. And each and every one of those proofs, it may be a sub goal, like not the ultimate goal, but part of the goal to get 2 triangles to be congruent. That's the sub goal. You could be using isosceles triangle theorem or the converse, etc., or like definition of angle bisector, definition of midpoint, CPCTC. But yeah, so any questions, please start typing. And let's see, we'll get started on the review. So again, 4 proofs, like pretty much they're all blank, just kind of like the quiz, except one of them will have like one little hint. And then just like the quiz, there'll be like the front side of your partner quiz, there were around maybe 8 problems where you have to identify what triangle it's congruent to. So you name it with the letters. And for all of those, you would have to make sure to place extra labeling. How many 6-step proofs? There's like the one with the combination, Evan, is that what you're talking about? So for instance, you prove one triangle, one pair, though there's one of those, one just like the quiz, only one, but then the other 2 will be something related to, triangle ABC is congruent to triangle DEF because of SAS and then all that. And then one of them might not be related, just like your quiz. If you look at the front side of your quiz, number 11, that one had nothing to do with 2 triangles being congruent. So it could be something like that. Chapter review worksheet. Okay, let me find that. Chapter 4 review worksheet. Sure. So let's do the last 3 problems. Is that V, is that number 22, 23, 24? Is that what you're referring to? Chapter 4 review worksheet. It's that, or I know I don't have you as my student, so, or are you talking about, I guess, V, could you type like what it looks like? Oh, okay, I think I know what you're talking about. This is what I gave my class today. Thank you guys for answering Emma's question. Yes, there will be 4 proofs on the test, just like the quiz. 4 proofs. Okay. So the first request, is there anything where you have to use the converse? I don't know. I don't want to answer that specifically. But you may have to use it somewhere, yes, but I don't want to say it's on the proof, or I don't want to say it's in the math part, but I mean, for sure somewhere you will be using the converse. I just can't specify exactly where. For instance, this is the somewhere. You might use the converse of isosceles triangle theorem. This is the somewhere where you could. So let's say these are provided, right? And then you have 3x plus 2 and 4x, I don't know, plus 1, and then 2x plus 5 or something. I have no idea if these numbers will come out right. But this is when you use the converse of isosceles triangle theorem. It's when your angles, so the converse of ITT is order matters. It's when if 2 angles are congruent, which they are in the picture, then the conclusion will be 2 sides. Sorry, that's very illegible. Two sides are congruent. So you're like, which sides? Well, they have to touch those angles. Like it's going to be across from each of those angles. So then it will be the 4x plus 1, and it's going to be across the other angle, which will be 3x plus 2. So in other words, this is not important. And then we set these equal to each other, and I believe x will equal to 1. And then you plug it back in if you need to. So 3 times 1 is 3 plus 2. So this is 5 units. And then 4 times 1 is 4 plus 1 is 5 units. So that's when you would use the converse. And let's see, let me kind of catch up. Can you see converse of, oh, so you don't have to. When you're trying to say definition of midpoint, it could go both ways. Definitions are not like, it's not like a converse where it has to be in a certain order. So if I had a picture, just a simple picture, AMC, and let's say in my given, I said AM is congruent to MC, and then I say M is the midpoint of AC. The reason is definition of midpoint, right? That's unusual. We hardly see that. We usually see it the other way around, where they say M is the midpoint of AC. That's like given. And then you would say, oh, then I have to put tick marks on segment AC, like, and then I would say AM is congruent to MC, and that's still a definition of midpoint. So in other words, it doesn't matter the order of how you're given. You could be given sentence to a congruent sentence, like statement, or a congruent statement to a sentence. It's still the same. You don't have to say converse. So no, you don't have to. You can, but I don't think it's necessary. So let's see. We called it isosceles triangle theorem. So and algebra number 13 as well. So I was just kind of explaining a couple things. So let me go back to, I'm going to write down the questions. I'm going to go back to chapter 4 review worksheet number 6 through 8. It's on the back, last 3. And then quiz number 13, partner quiz. Okay, those are the questions I see so far. If I missed your question, you may have to retype it again. Yes, Taylor, that's usually the situation. I know for sure Miss Bratcher does that too. I just talked to her yesterday. So yes, she requires you to first say, so for instance, sorry, I'm kind of answering questions out of order and I apologize for that. But let's say you had a triangle and it said AC is perpendicular to DB, that's given. So this is answering Taylor H's question. So then the next step you would say is, well, if they're perpendicular, they create these 90 degrees. So you'd say, let me number them, angle 1 and angle 2 are right angles. So definition of perpendicular is fine. Then you would, if you're trying to do side angle side, let's say these were given, okay, I'm just pretending, but let's say those were given and we're like, I want to do side angle side soon, then I would have to say they're congruent, because I always want to have congruent marks, and that will be all right angles are congruent. Okay, so yes, that is the case. When do we use hypotenuse leg? Great question. I'm going to write that down. So then I'll try to go, when do we use, oh, and someone actually answered the question. Thank you. And I'll maybe get back to it to clarify, but great job. Thank you. Yeah, that makes it actually really clear, Matt. Hypotenuse leg 90. Yeah, that's totally helpful. Okay, so I'm going to go back to one of the questions. If you didn't get this handout, I guess it's just extra practice. So let's see, here's number 6 from one of the worksheets. This is chapter 4 review. I gave this today. So here are the tick marks. So step 1, I know this is an equilateral triangle because all sides are equal. And if all sides are equal, then all angles are equal. You could approach this 2 ways. You know all 3 of these angles are the same. They're all 2x plus 10. So you can technically do this. I don't recommend it, but if this makes the most sense to you, feel free. It just takes a little bit longer, okay? But it's not a wrong idea. So that's step 1. You can do that and you can solve for x, okay? But here's a different perspective. Let's not even worry about any of these other ones, right? If we look at an equilateral triangle, each time they're going to be 60 degrees each, like no matter what. 180 divided by 3 is 60 degrees each. So therefore, I don't have to do that whole equation. I can just do 2x plus 10 is equal to 60. It's really the same thing because this top equation up here is the same as 3 times 2x plus 10 equals 180. It's the same exact thing. It's just, putting it in a different perspective. And if you divide both sides by 3, we're going to get 60, and we're going to get 2x plus 10. So in this case, our final answer will be 25. Okay, that's number 6 from one of the handouts. Let's see. Then number 7 on the same handout. It's I think this was from the textbook actually. So this one is 25, and those little like markings right here means they're congruent. Okay, so this is 25 degrees. I think the book didn't do the best with labeling it. This should have had like 2 tick marks like that. So this is x degrees. So the big picture, if 2 angles are congruent, I'm like, oh, this is not 25. If 2 angles are congruent, then 2 sides are congruent, which means this is converse of ITT. I don't really need to use that fact. Like I just could solve it, but I'm just trying to relate to when, if you had to. Good job, guys. So then the next one would be is now we have to calculate it. So this angle also is x degree. If you look at the big picture, the big triangle, that means it's x plus 25 plus 25 equals 180, which makes this 2x plus 50 equals 180. And then that means x would equal to 65 in this case. And so you can double check. You can say 65 plus 65 plus 25 plus 25. That total is 180. Okay. Yes, Mrs. Tira. Let me see. Do you mean number 1? I'm sorry. I haven't been reading the chat in a little bit. So how do you do isosceles triangle proof? Okay, I can do that one too. That one is, I think like the quiz. Let me do that. Just write that down. How do you do? Riley has a question. Yeah, thank you. Do an isosceles triangle. Thank you for doing that. That's helpful. So I don't skip it. Okay. And then number 1 on the chapter review. Let's see. That too. I could do that one too. Thanks, Emma. Okay, so then let me do one more to answer the chapter 4 review question. So here's number 8. So then this is using the old fact, linear pair. So to find x, these two add to 180. So x is equal to 45 degrees. Then, where else is it? oh, these tick marks were here. So if two sides are congruent, then two angles are congruent. That's the isosceles triangle theorem. So since this is 45, y is also 45. Like no calculation needed. Boom, 45 degrees. Okay, and then z is up here. So you could do the triangle exterior angle theorem. If you recall that from last chapter, you add these two remote interiors and it's equal to the exterior. Or you can do just all three angles add up to 180. That's your choice. So since we already have 45, 45, and blank, you could figure that angle out, and that's going to be 90 degrees. Or you can look at z 45 and 135 and say z plus 45 equals to the exterior, and you get the same answer. You get 90. So these are your final three answers for that one. Okay, so let's now, so we did this one. I'm going to cross it out. Then partner quiz number 13, and then I'll talk about, you're welcome, V. How do we do HL? Okay, so this is number 13 from the partner quiz. And this was a pretty good one because it incorporated last chapter 3 stuff, the converse of parallel, the converse of corresponding angles, etc. So let me draw the picture first, and then I'll try to label everything. Okay, these are parallel. I have F, I, N, C, H. And the numbers are here, so that helps us identify the angles easily. Okay, so there was some given information, and this was a six-step proof. And what was given? So what was given is FI is parallel to NC. So that's already marked. And then another thing that was given was FI, the segment, is congruent to segment NC. And so I'm going to just write that one down really quick. FI congruent to NC. There's more given, okay? Like I'm not writing everything down. I just can't fit it here. And the last one is N is the midpoint of FH. Okay, so let me label that. N is the midpoint of FH, meaning this is going to have tick marks now. N is the middle of segment FH. So that was all given. I can't write it all down, okay? So if I want to use the very first fact, which was parallel, okay, so they said the lines or sides are parallel. We have one transversal that touches those parallel lines right here. And there's 4 angles that touch that transversal. However, we need to pick 2 angles that touch the parallel lines as well. So therefore, our 2 angles, if I were to redraw these just to give a different perspective, and here's 1 and here's 3. These angles back in the day, meaning chapter 3, those angles are now congruent because of the corresponding angle theorem. So using the fact that they're parallel lines, I could say angle 1 and angle 3 are congruent, and I would write corresponding angle theorem. I know McKee and Haygood would, and possibly Bratcher, I'm not sure, would write if parallel lines, then corresponding angles are congruent. Like you would shorthand, right? That's okay. You write that as your reason. So now I need to write down the fact that the midpoint happened. So if the midpoint happened, I already marked it in gray. I could say Fn is congruent to NH by definition of midpoint. And so at this point, look at your picture. I tried to stress this with my students today. Look at your picture. I have a green marking. Let me make this to blue. I have a blue marking in the picture and I have a gray marking. And in my proof, I have a green congruent marking, a blue congruent marking, and a gray congruent marking. So we have matched everything from the picture to the statements. We have 3 tick marks in the pictures each and 3 congruent marks in the statements. So we're ready at step 4 to say triangle fin is congruent to triangle NCH. So N matches with F, I matches with C, N matches with H. Okay, so that's, now you're like, oh, how are they congruent? So let me just draw one. Here's a tick mark, here's an angle mark, here's a tick mark. Now if I drew the second one separately, it would look like that. So that would be side angle side. Thanks, Evan. That's step 4. And you're like, oh, I thought that's the end. Sometimes, right? So there's the 5-letter acronym that always goes after that. And some of you are typing, yes, corresponding parts of congruent triangles are congruent. Yes. So this is where you have to pick very wisely. Okay, I know my ending. I want to say IN is parallel to CH. So I would pause here because you're like, I'm stuck. I don't know what to write. So you would want to probably work backwards instead of forwards. So back in the day, chapter 3, when you had to prove lines are parallel, you had to use converse of something. And I know I stressed upon that. So then if I go back to the picture and I want to prove IN is parallel to CH, it's not right now, right? But if I want to prove that, then I look at the angles that are touching segment IN and segment FN. In between, there's this angle 2. And what's touching CH and HN is angle 4. Well, if somehow I can say those angles are congruent, then it forces these line or segments to be parallel. That's from chapter 3. Okay, so I know I want to say angle 2 is congruent to angle 4 because that's just how I can get the converse to happen. There's no other, angles that are visible. So, and that are touching those parallel lines and transversal. So out of the unmarked spots, so, this is wrong, like I and C, you could do CPCTC, but it won't help you prove lines are parallel. And then these 2 sides, yeah, you can use CPCTC to say they're congruent, but that won't prove that the lines are, or the sides are parallel. So you say, oh, I have to use 2 and 4. So then just, if you ignore the whole problem now and just say angle 2 and angle 4 are congruent, now it forces the segments to be congruent by the converse of CA. If you're in Haggard or McKee or possibly Bratcher, you might have to write the shorthand sentence. You write, if CA is congruent, then the lines parallel, right? Something like that instead of that. Let me see a couple things I want to read. You only use CPCTC when you prove the triangles are congruent. Yes, Tate, after the triangles are congruent. That is right. Quiz number 3. Right. Okay, so then now when do we use HL? Okay, so to use HL, I liked how someone did this. They did HL 90. Right, that's so true. Like all the other ones have 3 things. Like SAS has 3 things. S side 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 has 3 things. Angle side angle has 3 things. So for HL, you must show hypotenuse are congruent, legs are congruent, and 90 degrees. So you have to show 3 things still. So if I had 2 triangles, something like this, and A, B, C, D, When do you use HL? Well, you have to make sure that the hypotenuse have tick marks. So the well, first of all, let me draw my right angles. The right angles are right here. Okay, so AC and BD are perpendicular. That's given. Okay, so that makes it 90 degrees. And then I need to force these to, like, that has to be given or some, like, no matter what for this one. You can't just put it there. So let's say AD, these are all given statements, okay? These are congruent, given. And then you just need a leg. So if I were to do this in a proof format, I would say, given. And then number 2, you would want to say definition of perpendicular, that I'll put numbers. Oops. Angle 1 and angle 2 are right angles, or you could say 90 degrees. You could shorthand for some of the classes, right? And then that's like, this is a requirement. This is needed. You need to say something about 90 degrees because that's a requirement for HL. But then I already had one given, right? AD is congruent to CD. And if you look at the picture, those are the hypotenuse. So I got hypotenuse, I got 90, I just need leg. Now, some of you can say yes or no, am I allowed to just say AB is congruent to BC? Is that legitimate for here? Could I say that? No, we can't. Like, I don't know if B is the midpoint. Thanks, guys. So I have to say something else. And you're required in this case to say legs. So which leg? It would have to be BD, the middle, yeah, is congruent to BD. So, Andrew, I'm sorry, I'm not sure. I know every teacher does it a little differently. So Andrew, could you recap what your teacher McKee requires you to write down for the HL proofs? At least this is for Bratcher. I know Bratcher and I have the same format. So we say hypotenuse are congruent, we say 90 degrees or right angles, and then we say legs are congruent. So I think Andrew can help us write it down. I hope he's typing it. Okay, all right, so then number 4, we're ready to say the triangles are congruent by HL. So like ABD with CBD, okay? So it's slightly different for HL compared to SAS or ASA, etc. So 25 on homework, okay? So how do we use HL? I feel we kind of just did one example, but I could come back if that's still unclear. How do you do an isosceles triangle proof? There's different kinds, but the big idea is to, like, if your goal is to say a triangle is isosceles, like let's say the goal is triangle ABC is isosceles, like that's the goal, right? Then I know it's probably going to be something to do with definition of isosceles triangles. So now I have to figure out, before that, like I got to draw a picture, right? So let's say here I have A, B, C, D, 1, 2, 3, 4. So let's try to prove, and let's try to prove that, oh, I need another letter, E. Oh, it's not even ABC anymore. Let's do ABD. Sorry, I gotta change it up because it doesn't match my picture. So let's prove ABD is an isosceles triangle. So in this case, I gotta give you some information. The first thing is given, and the given is EC is parallel to, what's it called? I can't think right now. EC is congruent to AD. So from there, I get to put those arrow marks. Boom. Boom. Then now we gotta think back to chapter 3 because there's a couple corresponding angles in this picture. I gotta give you one more piece of information. I'm gonna say angle 1 is congruent to angle 2. So EBC is isosceles eventually, okay? All right, so then let's use some corresponding angles. So if the lines are parallel, 1 and 4 are congruent because they're corresponding angles. And another set is angle 2 and 3. So the reason, at least for Tira would be corresponding angle theorem. For McKee or for Haygood, it will be if lines are parallel, then corresponding angles are congruent. Yes, I will talk about that medicine difference. Okay, so then next would be, I want to ultimately say 4 and 3 are congruent. Okay, I want to ultimately say that. So if I replace this red 1 with the 4, now I have angle 4. And if I replace this red 2 with the 3, it's now congruent to 3. So I did substitution or transitive. So I replaced it. So now if you look at the big picture and saying 4 and 3 are congruent, then, oh, I'm sorry, I don't think this is the right reason. I kind of jumped to conclusions. Then I can say that AB is congruent to BD by converse of isosceles triangle theorem. So when do you use converse is when you're given angles are congruent, then the sides are congruent. That's when you use converse. Oh, and so how are they isosceles? It is definition of isosceles. Sorry, that was correct. So our final result is since two sides are equal or congruent, then it has to be isosceles. It goes vice versa. Definitions always go both ways. So let me clarify a couple things. You're welcome. Let's see, there are given. Oh, so Matt, I'm going to come back to your question. Brooklyn. I'll put this copy and paste. Let's see, where did I lost it? Oh, here it is. Madison had a good question. Let's see. Okay. They're just given. Okay, so let's see. The big difference to answer Madison's question is, I'm sorry, I'm going a little out of order again, but just to have that relation to what I just did. Definition of isosceles is just stating the fact that, like, here's ABC, that two sides are congruent. The answer is two sides are congruent. So it might be these two. It really depends. So AB is congruent to BC. So for instance, when do you use definition of isosceles triangle? If you had a statement that said ABC is isosceles with base AC, so that's the one you're not going to put tick marks on, then you say AB is congruent to BC by definition of isosceles. That's when you would use it. When they stated it's isosceles, then you use the definition of isosceles. And all you can say are the sides are congruent. That's the immediate response. And remember, this could go vice versa. I could have gone the green to red, and it's still definition of isosceles. Okay, I know it's unusual, it's uncomfortable. Okay, versus the isosceles triangle theorem. That's when you have to have a beginning and an end. So the beginning would be Like this has to be given. It's not interchangeable. If it is interchangeable, it will make it converse. So we have to state two sides are congruent first. Two congruent sides is always the given. Two congruent sides. So in this case, AB is congruent to AC. Right? Let's say that's given. Then your conclusion using the ITT, isosceles triangle theorem, is angle B is congruent to angle C. So it's in that specific order for isosceles triangle theorem, right? Two sides are congruent. Okay, it's isosceles. So what next? Angles are congruent. Okay, versus the converse of isosceles triangle theorem is backwards. You have to be given two angles are congruent. And then what does that conclude? Two sides. It's just literally backwards. So same picture, BCA. So angle B is congruent to angle C, given. Then I can say the two sides are congruent after. That specific order yields to converse. So, I'll write it all down here again. Versus ITT versus converse of ITT. So given this picture, A, B, C, these two are congruent. Okay, so definition of isosceles would just say two sides congruent. That's if you had triangle blank is isosceles. That's like what's given. For ITT, you would have to say two sides are congruent, then two angles are congruent, and lastly, converse, you're given two angles are congruent, then you can conclude two sides. So each one of these has a different given, but two of them, this one here and this one here, has the same ending. So just be careful. It's what's given. If you're given something, something, something is isosceles, using that, you can use definition of isosceles, or something like two angles are congruent, then you can use converse of ITT. Sure. Okay, let me reread. Did she make a mistake on the previous? They give you angles and you go to sides, it's converse. Red caution sign on the top saying, oh no, I have no idea. Oh, I see that too. It's not just you. I have that too. I have no idea. Approaching the max text limit to prevent a data loss. I have never seen that. Oh, I don't know. So I'll let the tech people know. Okay. Brianna, I'm not sure what you're asking because when would you put isosceles triangle theorem in a proof? Oh, okay. I don't know. Did I answer a question or no? I'll try to clear it later. Yeah. And then number 14. So can anyone answer Brianna's question? She said, when would you put an isosceles triangle theorem in the reasons proof? So when would you use ITT in the reasons? I think I showed you guys here. You would use that when you're given two sides are congruent and you're trying to prove angles are congruent. That's when you would use ITT. But you must be given two sides are congruent. Okay, let me go back in order. Okay, so let me go to quiz number 3, then 25 on the homework, and like number 4, etc. Would you put it at the end? I don't know when it will. Brianna, I don't know if it's like the last step. That's not always the case. It could be step 2, it could be step 3. But if you're somewhere in your proof, somewhere above, it says two sides are congruent in the triangle, then you can say two angles are congruent. That's when you would say ITT. It doesn't have to be at the very last step. No, it could be in the middle. It could be like toward the beginning. So hopefully that kind of helps you. But you must have somewhere in the proof above in the statement sides, the sides are congruent. Then the angles are congruent. Okay. All right. So then number 3. Okay. So that one is the one with the parallel stuff, I think, right? So we have GOLD, gold. And there was already the parallel markings. Here are parallel markings. There's a transversal. And then there weren't numbers in here, but I'm going to put numbers just to make it a little easier, a little bit for the eyes. So like 1, 2, 3, 4. So if, was there anything else? That was all that was labeled. So we have to label everything. Okay, so if I split this up, here's GD and OL. And the transversal, the only angles that exist are 1 and 3. And if you recall from chapter 3, these angles are now congruent by alternate interior angles. So I would mark it here with a 1 mark and a 1 mark. Okay, then I'm going to label GO and DL. Those are parallel, same gray transversal. And the only angles that exist are in this new picture are 2 and 4, and those are also alternate interior angles. So because the lines are parallel, the alternate interior angles are congruent. So I'm going to put another angle mark, double time this time, double time. So you're like, oh no, there's only 2 angle marks in one picture and 2 angle marks in the other. So that means you need to look at that transversal, that shared side, and put a tick mark. Boom. So if you split up the picture GDL, and I'm splitting up OLG, G, so double and single, these are congruent. These two are congruent by angle side angle. So this is number 3. So G, D, L is congruent to triangle blank, blank, blank. So we should label this G, L, D. So G in the original one has 1 tick mark, 1 angle mark. And in the other picture, L has 1. So L has to be first. Then D has nothing. It's empty. So O is empty. That has to be O next. And lastly, L has 2 angle marks. That matches with G. So it has to be triangle log. And they are congruent by angle side angle, in this case, for number 3. Okay. Worksheet 4. I gave one more worksheet today, period 1, period 5, period 6, yes. And I know period 1, we didn't go over it, but period 5 and 6, we went over it a lot more. So I gave the mini quiz, yeah. Okay, so then Samantha, I don't know where your question's coming from. Where did I get the second step? Is that old? Yes, Nicole, I could do a double proof. Okay, overlapping. Yep. Okay, so let me quickly answer the questions from earlier too. So let me erase these. Okay, Brooklyn, number 4 on the mini quiz. Where's my mini quiz? Oh, this will answer your guys' question. This is the overlapping one. So, oh shoot, I'm going out of order. 25. Let me do 25 first, just because that person's been waiting for a long time. 25. Let me go to that page. And number 25. Oh, okay. This one won't take as long as the overlapping, so I'm glad I did 25. This is the homework number 25 from the textbook. So we have a triangle. Oh, it's isosceles because two sides are equal. So by definition of isosceles, this is, right, two sides are equal. So automatically x is 4 just because they have the tick marks. Okay, then we have a 50, a y, and that's it. Okay, so because two sides are congruent, right? So then we can say two angles are congruent by the ITT, isosceles triangle theorem. Okay, in that specific order, we're given two sides, so now two angles. And where do they go? It goes down here. It's across from side X and it's across from side 4. So that means this is also Y. So you can do it algebraically. You can do y plus 50 equals 180. Or you can do it more like, okay, 180 minus 50 is 130. And then you can divide that by 2 because there's two y's. The same exact thing. So y will equal to 65. Okay? All right. Let me see. Yes, I'll definitely do overlapping. It's coming. So Brooklyn asked number 4 on the mini quiz, which is the overlapping one. So I'll do that. Overlapping triangles. And then what is the difference? Oh, I think we talked about Madison's question already. And then number 14. Okay. So from the mini quiz that I gave, I don't think every teacher gave, but it was just extra practice from 2 days ago, is looks like this. And I think it's from the book. So number 4 from Tira's mini quiz. Overlapping triangles. Okay. Let me try to draw it first, and then I think the most important thing for this is we need to know how to redraw the pictures and plan ahead on what triangles to use. Without that, it's going to be very difficult. So we need to plan. I'm going to put tick mark soon and then label the side. This is T and S. Okay, so there's things that are already marked there, like that's given. So PS and RS are already congruent, and these two angles at the bottom are already congruent. Like that's just given to us, okay? So I know I did this in my classes today, a few classes. I don't know if I did it for every class, but I highly recommend to draw the triangles. And for this one on the quiz and the test, you were given Miss Bratcher, I think she says she made an extra credit, Evan. I think that's what she told me yesterday, because I guess time or something. But yes, you had that question. So for this one, let's see. If I draw the big triangle picture, so that's P, Q, R, S. Oh, sorry. Where is that? Evan, never mind. I don't think she did. I don't think Miss Batcher did. Sorry. So we have one big triangle and another big triangle. There's more. I'm gonna draw all the sorts. Then there's the smaller diamond looking triangle. So that's P, Q, R, T. And then lastly, there's this really hard drawing one. So there's this obtuse looking triangles. P, T, R, S. So if you're able to visualize all of these sets of triangles, you are already ahead of the game, okay? So now what we have to do is we need to, and again, it's going to be easier for you guys because it's going to be already given to you in the proof. It'll tell you what triangle to choose. So I wish I had more space. I wonder if I can do this. Let me do something that I've never done before. I don't know if it'll work. I want to make another whiteboard. Can't find that option. Notes. Maybe I have to ask the IT people tomorrow. Okay, sorry. I wanted to make 2 whiteboards. I guess I could just make this bigger. Okay. Okay, I'm going to hide all the conversations for now. Oh, it doesn't change. Never mind, never mind. That didn't do anything. Okay, so in a situation, like there's going to be a mid-step, okay? So, for instance, it'll say like at step 3 and then step 6. Step 3 will say triangle PQS is congruent to something. And then step 6, the ultimate goal, it'll say what you really want to prove. Like QPT is congruent to blank, right? So this is a huge hint. Look at that and look at green, yellow, blue. Out of those, which triangle is for step 3? Green, yellow, blue. Someone could put in the chat box. Green, yellow, blue. Which one identifies step 3? Okay, I got one green. So yeah, so you guys can stop your chat. Thank you, thank you. So we have to look at this first. Okay, so this must be your first objective. You're trying to prove those triangles are congruent. Well, guess what? You already have 2 labels on there. You just need one more label. And I hope you guys see it. What's that extra label you can place on that green picture? Yep, the shared side. So step 2 would be QS is congruent to QS. Sorry, I can't write everything. And the reason for step 2, I'm going to see if I could type it here. The reason to step 2, reasons, I'll type it over here in the middle, is reflexive. I just don't have room. POC, property of congruence, okay? So now those 2 green triangles are congruent. I would say PQS is with RQS. So don't worry, you'll have a clue. You'll have what triangles to use. And then now you know, okay, now you have 2 choices. Can you write either yellow or blue? Which yellow or blue is the one where we're trying to prove number 6, step 6, yellow or blue? So yellow or blue? Yellow, right? Okay, so you can stop. So this is your second goal, which means we don't need the blue at all, okay? So the yellow is your second goal, step 6. So in between for step 4, okay, so I'll write step 4, we need to use CPCTC. But the important thing is, and I hope I stress this enough with my students today, is that whatever in the green picture has to match in the yellow picture. So if you look, let's just brainstorm. I know some of you already know the answer, but look at angle P and look at this angle P, looking at this picture and this picture. Those are not the same size. Yes, the letters are the same, but if you look back in the original picture, they're not the same size. Therefore, it's useless to say angle P is congruent to angle R, because angle P over here and angle R over here is totally different from this tiny angle and this tiny angle. So that one is a useless piece of information for CPCTC. Okay, so do not use that for step 4, CPCTC. That's not going to transfer from green to yellow. Okay, then you have to see what else is not marked in the green. Well, notice how this PQ is not marked and QR is not marked, and it's on the yellow. So that's something very important we want to use for the next step, because we want to label the yellow. Nothing is labeled on the yellow. So then now I need to say for step 4 is segment, I'm writing it in the middle. Okay, I don't have room, that's why. Segment PQ is congruent to segment QR, and the reason is by CPCTC. Okay, but that's not enough, right? Like just that alone is not enough. So here and here, so I got tick marks, but that's not enough. I need to put more. I need 2 more tick marks. So then I gotta look back at my picture and say, what about angle PQR, the top angle, and angle PQ, I'm sorry, RQ, what is that, S? PQS and RQS, right? Those top angles, they transfer over. They're the same exact angle here. They're the overlapping angles. So now I also want to say that in step 4. So I'm going to have like a semicolon. I'm going to say angle PQS is congruent to angle RQS. Some of you might write angle PQT, and some of you might write angle RQT. Sorry, it's not capital. Oh my gosh. That's, I think, okay. Those are both appropriate, okay? So now I have a lot of markings. I have 2 markings in each, so these are now congruent. I put my angle mark. And now for step 5, before step 6, I have to use the shared side. So congruent to QT, I don't have the segment bars. And then step 6, these are congruent triangles. The yellows are congruent by SAS. Oh, sorry, this is by reflexive POC. All right, whew. Okay. On the quiz, you put segment PQ is congruent to segment PQ for CPCTC. Oh, on the quiz? Are you talking about the mini quiz? Oh, it says it's in red, right? On my mini quiz that I took a picture and sent to remind, it says segment PQ is congruent to segment RQ. Taylor, I hope we're talking about the same thing. Okay, what's the reason for step 3? Oh, sorry, I never wrote that. Yeah, the reason for step 3, the back to the green picture, is side angle side as well. Yeah, just coincidence. It doesn't have to always be side angle side. Okay, Samantha. Okay, let's see. So that answered the overlapping triangle and the mini quiz. And then number 14, I think is that the overlapping one as well? Yeah, that is. So I know it's repetitive, but it's good practice. So I'll do that one. And we might have to make this our last one. So from the quiz, I'll draw the picture. Just word of advice, just because you see a right angle doesn't mean it's going to be always HL. Okay, so let me side note. If I had these as my tick marks, let's just say that was given, this is not HL because the H, the hypotenuse, is not labeled. This is instead side angle side. So just because you see a right angle, it's not an automatic HL. Okay, you have to see, is my hypotenuse labeled and is my leg labeled? But if your picture was same exact picture, so I'm sidetracking. If you had a tick mark on the shared side, and if you had a leg like this, then yes, this is HL because the hypotenuse is marked. Okay, just giving you a difference. Okay, so the quiz number 14. All right, let me draw the picture. And just like the test tomorrow, number 14 has a clue. So you have step 1 through 6. I'm going to write it in the middle here. I think it's easier to type. Step 4 has a clue. Triangle ZEB congruent to triangle blank. Okay, so step 1, you look at your picture, and when it's overlapping, when it's a 6-stepper like this, you should redraw the picture for what's it called? Step 3. That matches step 3. So tick mark, tick mark. Okay. So because step 4 has triangle ZEB, you want to redraw that because it's hard to label it. So ZEB and ZAB. I'm sure you're like, I already know that's the answer for step 3 or 4, but how? So this is marked. So what's given is EB congruent to AB, then ZE perpendicular to EB, and ZA perp to AB. So that's by given. Okay, then number 2, it doesn't have to be number 2, it could be number 3, but number 2, I'm going to try to say something about the right angles. Well, let me plan ahead. Like looking at the green picture, this is for step 3. I keep saying step 3, this is for step 4. The triangles are congruent. By looking at this picture, I just need to put that shared side, and I have to decide now before I start writing stuff, is this is going to be HL. Oh, this is 6, 7 steps. No wonder I keep getting thrown off. Thanks, Kyle. So then I have hypotenuse leg in this situation. So if that's my goal, I already know step 4 is going to be hypotenuse leg. Right? That means I need to say 3 things. I need to say hypotenuse is congruent. The, what is it called? The legs are congruent, but that's already said. So I'm going to make this red up in the middle. So that's already stated. The legs are congruent. So legs are congruent. That's done. Now I need hypotenuse congruent, and I need to say 90. So step 2, I'm going to use the perpendicular. I'm going to say angle E or angle ZEB is congruent to angle ZAB by oh no, not congruent. I want to say right angle. What am I doing? And is 90, or you can say right angles by definition of perpendicular. Okay, that could be step 3. And then the reason why I didn't want to write congruent is because I'm trying to use HL. So this is the 90 degree. I'm going to color coordinate. So far I got 2 out of 3 things in my checklist. So then now step 3, I need to say the hypotenuse is congruent, and that's ZB is congruent to ZB. And that's by reflexive POC, property of congruence. So according to HL, I got it all done. I said the legs are congruent, that's in red. I got the angles are 90 degrees, that's in red. And I got the legs are hypotenuse are congruent, that's in red. So now I am ready to say they're congruent in step 4. So triangle ZAB. Oh no, I pushed the wrong button. ZAB, Z-A-B, by hypotenuse leg. Okay, so now I have to look at step 7, and that's like for sure given. It says triangle EBR congruent to triangle ABR. And so I need to redraw my picture for that. So let me erase a couple things. Definition of right angle. Kind of. Taylor, kind of. Definition of right angle is when it says something like angle A is a right angle. Then you say it's 90 degrees versus definition of, I guess, but then in this case, we're not going to use definition of right angle because I didn't see any right angle. You know what I mean? I didn't see any 90s. So that's, only difference. Let me clarify a little bit after, okay, Taylor? I'll get back to you. Sorry. Just trying to delete these. Okay, so now I have, that's true too, Evan. Yeah, that is true. The definition of right angle is just one angle. So my goal, oh shoot, I didn't put the letter R here. My last goal is to draw EBR. So I'm going to use yellow. So EBR, because that's step 7, and ABR. So now the important part is we're going to use CPCTC. I know that right off the bat. I'm going to use CPCTC and try to figure out what information I can use from the green picture to the yellow picture. Now that's our big goal, from green to yellow. What can I transfer? Let's think ahead. So I have this angle here. These two I'm marking in gray. Does that exist in the yellow picture? Yes or no? And uh-oh, I think, okay, my internet's kind of getting a little bit off. So then the answer is no. So that's not useful, okay? Saying that that angle, those angles are congruent, very useless. Does ZE exist in the yellow picture? And the answer is no again. That's useless information. So that just leaves me to one more unmarked spot, which is this angle on the right. Those two match exactly on the yellow. If you look at the original picture, they are the overlapping angles for both. So for step 5, we want to say, oh, and there had numbers in the proof. So hint, hint, use those numbers, right? That's a huge hint. So angle 1 is congruent to angle 2 by corresponding parts. So congruent triangles are congruent now. Okay, but that's not enough information. Like I only have 2 markings because EB was already there, AB was already there. So I need to make a third marking. And step 6 is the shared side. See? And that's RB is congruent to RB. And so now I'm going to highlight everything in what color? I don't know. I don't know. Green. So I'm going to highlight. No, let's do blue. Here's blue. And here's blue. My cursor's not working. Hello. Uh-oh, my internet's kind of going away. Okay. And then this one is blue. And back to the original is blue. So all of these blue items, will help us prove this magical ending. And if you look at the tick marks in our picture in the yellow, they're going to be congruent by, not HL, of course, because there's no hypotenuse, no right angle. This one's side angle side. Yeah, Mia. So look at the clue. Look at the middle step. That's step 1. Draw the picture. Then look at the last step. Draw that second picture. And try to show whatever you need to do to prove the triangles are congruent. Okay? So you'll at least have a clue for the overlapping triangles, but you do need to figure out the way to get there, okay? All right, well, we went a little over, but again, study your quiz. There are maybe 4 calculation problems, so make sure you know your facts about isosceles triangles. If 2 sides are equal, then 2 angles are equal. I know I did this with my class. Like let's say I had a 50 and an 80 and a 3x plus 5. I'm not going to do the whole problem. I'm just giving you one last little motion. And 5x plus 2. I have no idea if this is going to work. Sorry. So He's like, oh shoot, I don't know what this is. First, you would have to calculate this angle. That angle, that leftover angle is, let's see, 180 minus 130 is 50. So now I'm like, ooh, these angles are congruent, which means these two sides are congruent, which means I don't need 5x plus 2. The math's not going to turn out right, but you would set these two equal to each other. Uh-oh, my computer's crashing. And then from there, you would say x is whatever. Okay, so you might have to figure out angles, like what angles are congruent first. Another set would be, come on, let's say you're given two sides are congruent and this is like 80 and, figure out these angles or something of that sort. Or, so there's a lot of algebra ones for tomorrow. Yeah, x equals -3 is a weird answer. So yeah, thanks for writing that. Cool, cool. Yeah, 50-50. I just did that. Yep. Okay, so study your quizzes, study your all your homework sheets. For Tia's class, you got all the answer keys sent to you through via Remind, so you can look through that. And let me just stop the recording, but I'll post the link, so just wait